notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1. All of those have already been published on YouTube in their entirety. Section 2. All 12 of those videos have already been published on YouTube in their entirety. Section 3. All 6 of these videos have already been published on YouTube in their entirety. So that's a total of 51 videos from these 3 sections. Please make good use of them. We are now at section 4, measurement. This is the 16th of 17 videos in this section. I am behind schedule. Then we have to do statistics, January 2025, behind schedule. Algebra, February 2025, hopefully we will be able to catch up. Then by March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, vectors and matrices. Please note this disclaimer. This schedule is just a projection which may or may not be fulfilled. It is not a contract with anyone. As pointed out before, all 33 of these videos from section 1 have been published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you look at those 33 videos from section 1 and know them well. Reminder also that you need to know the times tables 2 to 12. That is, if you already don't know them, then you will have to learn them, since calculators are not, I repeat, not allowed in paper 1. All right, from section 2, as already pointed out, all 12 of these videos have been published on YouTube in their entirety. Section 3, all 6 of these videos have already been published on YouTube in their entirety. We are now at section 4, measurement, and we are quite down here, so that those 4 videos there have already been published on YouTube in their entirety, and these others 2 and 3 and so on right down to 15 only partially published. We are here at objective 14, which deals with scale drawing, and it is actually video 16 in this section. This will only be partially published once it is finished. Scale drawing 4.14. Before we go on, recall I said in the introductory video that you will need a good math textbook, or maybe a set of 2, to get especially more practice questions. CSEC does recommend a set of books, these. Not all of them, but you pick and choose. From that set, I would recommend a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. Here is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer: I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you still need explained, you can ask AI Assistant either by text or voice, and most likely that will be explained to you. This is the URL for that site. And on the next slide, I will show you what the home page looks like. January 16, 2025. I will include a URL in the description below this video, so it will be easy for you to just click on it and go to that website. So this is the home page here that you see. You would have to register first, and subsequent to that, sign in. So this is a print screen from section 4. We have completed all 4 objectives from this section, as we just said. And this is page 2. We have completed all 5 objectives from this section. And now we are on page 3. These 4 more objectives that you see here on the left have been completed, so that we are now here, objective 14. Use scale and scale drawings to determine distances and areas. Now, we will not spend too much time on areas, because if you can use these scale drawings to find distances, you can easily use those distances to then calculate the areas. And we have done a lot of area calculation in previous videos in this section. This is just a reminder. This is the top part of the formula sheet that you will get in your examination, CSEC math examination. And this is the below part of that same formula sheet. So you don't have to learn these formulae. Just make sure you know when and how to use them. So as I said, we are here, objective 14. Use scales and scale drawings to determine distances and areas. Now, when objects in real life are represented as drawings or pictures on a paper, they are normally drawn to scale, that is, to the same ratio but smaller, generally, sometimes larger than real life. Think of a blueprint that an engineer uses to build a house or a bridge. Those drawings are much smaller than the actual house or bridge. Or the map of a village, town, or country that surveyors use to mark boundary lines. Those maps are much smaller than reality. The scale of such maps or blueprints are generally stated below left of the documents in one or more of 3 ways. So you may see it in words like that, that says 1 centimeter is equal to 50 meters. Or you may see it as a ratio like this, that says 1 to 5,000. Or you may see a graphic, a picture, or a scale as something like this here. Now, you're actually given a scale on the map. For 1 and 2, you will need a ruler, but in the case of this third one here, the ruler is already given on the drawing. So you don't need a ruler for the third one. So we will look at all 3 of these. In all 3 cases here, the drawing is smaller than reality. On the other hand, think of the drawings you have seen in your biology textbook of microbes. They are shown much bigger, much larger than real life. Such drawings are magnified with the magnification expressed as times something, maybe times 400, meaning the drawing you see in the book is 400 times larger than reality, or maybe times 1,000, and so on. Now, this means that the real size is 1 400th for that one of what you see in the drawing in your book, or what you measure in the drawing in your book. So for example, 2 centimeters is not really 2 centimeters, it's 2 multiplied by 1 over 400, which gives us 0.05 millimeter or 50 micrometers. Continuing, 4.14, use scales and scale drawings to determine distances and areas. Consider this Google Earth map shown here of North America. If we measure from the southernmost point in the United States, in Texas, to the northernmost point here in Canada, this yellow line here, we get this measurement. But that is too small for you to see, so let me expand it. So ground length is a little over 5,000 kilometers. So we will call it approximately 5,000 kilometers. From down here in Texas, United States, to up here in Canada, is approximately 5,000 kilometers. Now keep that distance in mind as we consider a similar map of North America that we saw previously. Let's revisit that map of the Americas we looked at in the last objective when we were trying to identify significant figures using the Atlantic-Pacific rule, this map here. So we just said that from up here to down here is about 5,000 kilometers. Now if we take a ruler and actually measure that on this map, we will get approximately 7 centimeters, which means that 7 centimeters on this map represents 5,000 kilometers in reality. So 7 centimeters represent 5,000 kilometers. Or we could say 1 centimeter represents about 700 kilometers if we divide that 5,000 by 7, approximately. So on this map here, 1 centimeter is about 700 kilometers. We are using different units here, centimeters and kilometers. Now this is one way of expressing a scale. Let's look at a second way, which is more convenient. We know that 1 kilometer is 1,000 meters and a meter is 100 centimeters. So if we multiply those two, we will get 100,000 centimeters in a kilometer. But remember we said 1 centimeter represents 700 kilometers. So now let's convert this 700 kilometers to centimeters. So 700 kilometers will be 700 multiplied by that number we got up here. And so we get 70 million centimeters. So let's rewrite that now in the same unit. 1 centimeter is equal to 70 million centimeters. Now that we have them in the same unit, unlike up here, where we had 1 centimeter is equal to 700 kilometers, now we have 1 centimeter is equal to 70 million centimeters. We can cross out that centimeter with that centimeter and we are left with this ratio, 1 to 70 million. This is more convenient and easier to work with, and this is a second way of expressing a scale. So somewhere on this map you should see scale 1 to 70 million. So if you take 1 centimeter here, it will be 70 million centimeters. If you take 1 inch on this map, it will be 70 million inches. If you take 1 whatever on this map, it will be 70 million of that in reality. So this is a scale drawing. It is drawn to scale, and the scale is stated as a ratio. Now, if you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. This is the second way that we already pointed out that a scale on a scale map could be expressed. 1 to 70 million.